Hello everyone and welcome to NetMastery Zone channel NMZ. In this video I'm going to design a network using a router on a stick. Maybe everyone, I'm sure everyone just heard about that, and it's a router on a stick. What does it mean and why we need this router on a stick? If you study for CCNA, actually the router on a stick is one of the most important part of I cannot say the most important part of that, but you may receive a lab in the exam for router on a stick. And actually, what is the router on a stick and why we need to use the router on a stick? Let's first create a lab for that, and after that we will start configuration, and during the configuration I will discuss about this router on a stick and actually the use case of that. First I'm just connected to my EVNG, and I just create a folder here, and in the lab and router on a stick, let's create a new lab here and name it router on a stick. Okay, this is version 1 and the header is NMC. Save. Okay, for that let's first of all let's add some node here, and here I'm going to use that images that I already have available here. For example, I'm going to use this one for a router, and it's okay, one router. I need one router here. This is my router 1, and add node. Next I need to have some switches. Actually here I have this iron image. Actually this image has a functionality of layer 3 switch, and if we use this functionality we don't need the router on a stick, but we don't need actually a router because it's a layer 3 and it supports the IP address, but here we are going to study the router on a stick. Then let's just use the layer 2 functionality of this. Let's assume that we have a switch, layer 2 switch like 2960, and it's only layer 2 and doesn't support any IP address. For that, let's make it switch 1, and let's change the icon also to a switch, a normal switch. Okay, I have router 1 and switch 1, and now let's have some client here. Actually, to after configuration we can verify our configuration and to make sure our configuration is working. For that let's create some let's have some virtual PC here. I can actually, I have Windows here. I can have Windows, but it doesn't need, it's a very load, and it takes our lab very big and busy, and because of that let's just use some virtual PC, and there are actually some command line that we can verify our configuration in that. I'm going to make 3 of it, and this is start with the VPC 1. Save. Oh, it's just name it to VPC 13, 14 and 15, and let's rename that to VPC 1, and this one should be 2, and this one to VPC 3. Okay, now we have 3 PC here, and 1 switch and 1 router. This router actually it's going to have 1 link to the switch, and because of that they call it router on a stick. It's only have 1 connection here. If you see the router, actually the router at least it should have 2 ports, and one for one network and another one for another network, and they should have different IP addresses in every link. But here as we are using the router on a stick. Because of that, we only can use one port, but we should create some sub interfaces in this. These sub interfaces, actually we just divide one interface, physical interfaces, to 3 sub interface, and put a different IP address on that for router functionality. Okay, let's connect our pieces to the switch first. I'm going to connect this one to port 1, PC2 to port 2, and PC3 to port 3, and I will have one port here, and I'm going to connect that to E00 of router 1. Okay, actually our lab is design is completed, and we don't need anything else in that. Let's start this lab and start our configuration and start all nodes. Okay, in the meantime that we are waiting for the startup and starting this lab, let me tell you that one thing, you know, difference between the layer 2 and layer 3. Layer 2, like switch, they are working using the MAC address, the physical address, and if this 3 PC is just connected to this switch and they had the same IP address in the IP address in the same network, then they can easily ping each other and there is no problem, and they are in the same network, and there is no need for any router here to route between these 3 pieces. But if this PC, for example, PC1 be in one network and PC2 and 3 be in another network, in this case, as switch 1 is a layer 2 switch and doesn't support any IP address, it cannot do the functionality of routing. And because of that, when PC1 is trying to ping, it's going to send a packet to the IP address of, for example, switch 2, and in this case, when it comes to the switch doesn't have the MAC address of this different network here actually, and because of that the ping will be unsuccessful and the packet will drop, and these 2 PC cannot ping each other if they be in different networks, and also same for PC3. Because of that, to solving this problem, for example, here we need to have 3 different network here, and in this 3 network need to ping each other. In this case, the existence of a router is very important, because they are in different networks and they have different IP addresses, and IP address, you know, it's neither layer 3 device to route between that, and because of that the router is very important to be available here. Okay, let's just have some, for example, text here. I'm going to write, for example, select some IP address for this different pieces, 192.168.1.0/24, and this is my PC1 network, and let me duplicate that and edit it, make it 2.0, and again duplicate, and this one is 3.0. Okay, as you can see here, we have a subnet mask of 24. It means that first 24 bit of the this IP address is belong to the network. Then we have 3 different networks here, because this is network 1, this is network 2, and this one is network 3. And in this case, if I just assign IP address to this VPCs, they will not ping each other because they are in different networks. And let's do that actually. Let's first go to PC1 and try to set an IP address to this. And let me check how I can ping IP address. Okay, IP, and I think we just write it 192.168.1. For example, for PC1 I'm going to select 2.100 with 255.255.255.0. It's 24-bit of mask. Okay, and this IP address is set actually, and let's go to PC2 and try to set IP address for this one also. IP 192.168.2.100 with 255.255.255.0. okay, this one is also set, and for 3 same. IP 192.168.3.100. okay, now we have 3 PC here, and everyone has an IP address, and let me try to ping. For example, I'm going to ping 192.168.1.100. This is the PC that we are already connected now, and we can ping ourselves, there is no problem. But if I try to ping it, for example, PC2, the ping will not be successful, because this is actually in another network. And even if I set a gateway, actually I don't have any gateway here, because I don't have any configuration in the router, and there is no gateway available here. But if I try to even set a gateway here, let me see how I can assign a gateway here. IP okay, IP, then mask, then gateway. Okay, let's set it again. 192.168.1.100 with 255.255.255.0, and the gateway 192.168.1.1. okay, now we just set the gateway here. Let's do same here. 192.168.3.1. this is the gateway, and for this one 192.168.2.1 and gateway for that. Again, there is not much different. If I try to ping 192.168.2.100, the ping will not be successful, because these 3, as I said before, these 3 PCs are in different networks, and switch 1 cannot route between these 3, because it's a layer 2 switch, and it cannot do any routing functionality here. Let's check switch 1, and let's check something. By default, this 3 port should be in VLAN 1. Let's check it. Show RAN interface is 0/1, and you can see it's let's do show VLAN. By default, we have VLAN 1 and its default VLAN, and we have these 4 ports in that. It means this all these 4 ports are in the same VLAN, and that is the default VLAN, VLAN 1, and still we are not able to ping. Okay, let's start our configuration by the switch. I'm going to create 3 VLAN here, and add these 3 PC, everyone in the 1 VLAN, and then try to configure R1 for routing functionality. For that, let's first put a host name for this switch. I'm going to name it switch 1 according to the name here, and then I'm going to create a VLAN. For example, I'm going to create VLAN 10 for PC1, VLAN 20, and VLAN 30. This 3 VLAN for 3 different PC that we have here. Now let's add the port E0/1 to VLAN 10. Interface is 0/1, and the switchboard access VLAN 10. Okay, and then port 0/2 to switchboard access VLAN 20, and port 0/3 switchboard access VLAN 30. Okay, now if we check our VLAN, do show VLAN, we can see that we have VLAN 10, 20, and 30, and these ports are assigned to these 3 VLANs. but still we have one port here, and this port is still on the default VLAN 0x1, and we are going to actually create a virtual interface here, and because of that this port should be trunk, and I'm going to let it like this now and start the configuration in the router, but in the next step we need to configure this port as a trunk, because we are going to sending, for example, I'm going to ping from PC3 to PC1, and this ping will first go to R1 and route it there, and then come back to PC1, and because of that this VLAN 3 need to be goes to VLAN 1, and this port should be trunk, because only trunk can forward or we can say that transfer the packet from the different VLANs, and if it being the one VLAN, it's just working in that VLAN, and it will not transfer the packets from other VLANs to anywhere actually. Because of that, let's go to R1 and try to make sub interfaces in this, and start our configuration. And first actually we need to create our gateways here that we assign in this PC. Let's wait for this to finish. Enable and conf-t. Let's put the host name on that. This is R1. Okay, do show run interface is 0x0. You can see that there is no IP address in this, and it's also shut down. Let's go in that interface is 0x0. First no shut it to make sure that's on. Okay, now we need to create actually sub interfaces in this interface. Okay, for the configuration, let's go to interface is0x0, and I'm just using .10 because for VLAN 10 here, and now I'm going to assign IP address like that, and this is the IP address 192.168, and this is 1, and the gateway we just select 1 here, and I'm going to assign 1 here with 255.255.255.0. And one more step that we need to here, you see that we just receive a error message, and because it's a sub interface, and the sub interface should be configured as one of this. It said that IEEE 802.110 or .1q. It means it should be .1q trunk, or it should be ISL VLAN, and one of this. Do you know the .1q is a trunking protocol, and it's open standard, and ISL is also trunking protocol, but it's Cisco protocol. It's introduced by Cisco, and it's only working in the Cisco devices. Okay, for that let's configure this encapsulation to .1q. Encapsulation .1q, and for example, I'm going to let's do this, and this is the it's need the VLAN ID for that .1q, and for that we have the VLAN 10 here, because we already created VLAN here, and we assign these ports to this VLAN. And now we just create this VLAN 10. Now we can actually assign the IP address to this. Okay, one port is completed. Let's get out and start configuration. The same port, different sub interface. Interface is 00 dot, for example, this one 20, and again encapsulation .1q, and I'm going to use 20 as a VLAN here, and then set the IP address to it. IP address 192.168.2.1 with 255.255.255.0. This one is also completed, and interface is 00 again. This time it's .30, and it just create another sub interface, and it's an encapsulation .1q. This one this time is 30, and IP address 192.168.3.1 with the subnet mask of 24. If I now check the interface here, do show IP interface brief, let's exclude unassigned. You can see that we have Ethernet 00.10, 20 and 30. Okay, now we have the gateway. If we try to ping from this VPC, we should be able to ping R1. Let's try that from VPC 1 and try to ping the gateway 192.168.1.1. No, we are not, because we didn't actually configure this port as a trunk. You see, this port is in VLAN 1 and it doesn't actually forward any traffic from other VLANs here. And now we need to configure this as a trunk. Let's do it. Quantity interface is 00 and switchport mode trunk. And before trunk, again, encapsulation .1q, switchport trunk encapsulation .1q, and then switchport mode trunk. Now our port is trunk, and it should be able to transfer actually all the VLANs traffic. Let's check it. Show interface trunk, and you can see that from VLAN 1 to VLAN 4094, the last actually standard VLAN, it's allowed in this. And you can see this is activated in the management domain, and this is VLAN 1, 10, 20 and 30. This is actually the VLANs that it's already activated in this. And if I check it here and do show VLAN, you can see show VLAN. You can see that we have VLAN here and they are active. Okay, now let's try to ping. This time we should be able to ping from our VPC to the gateway. Yes, and now we are able to ping from the VPC to the gateway here. And if I try that from VPC2 also, ping 192.168.2.1. Yes, I can ping, and from VPC3 also same, ping 192.168.3.1. Now I can ping the gateway, okay, and I should be able to ping other PC also. Let's try it. For example, the gateway of the another VLAN, for example 2.1. Yes, I can ping the gateway of 2.1, and if I try to ping 2.100, I should be able to ping it also. Now this router, actually we don't need to active any routing protocol here, and if we check the routing table, we'll see that this route is it will show the directly connected route here. Show IP route. You can see that this is network 1, network 2 and network 3, and all of them is C. It means directly connected. And if it's directly connected, there is no need for any routing protocol here to actually forward this route from one router to another router. Routing protocol, it's required when you just have another router here, and then you need to ping from this side to this one. In this case, then R2, for example, if we select R2 here, we'll need to run routing protocol or a static route between these two to access the PCs here. Okay, thank you for your watching. Please subscribe our channel. I'm trying to make every lab here practical for you. You may find a lot of detail about that in the internet websites and also Cisco documentation, but practical is something else, and you can find this lab actually in the comment of the video in our channel, and you can actually practice. I'm going to upload this lab without any IP address and without any configuration, and you can follow these steps that I try to configure, and you will be reached to the same configuration that I have here now. Thank you for your watching. Please don't forget to subscribe us, and See you in the next video.